Hello folks, welcome back. I'm working on Advent of Code 2023. My name is Alex and I'm doing this in both Elixir and Ruby. And this is day 2. I'm also going through my Whiskey Advent calendar as we do this process, although there's a deviation this time around because we had family movie night on Saturday night and I ended up not doing this recording. It's now Sunday that I'm doing this recording. The whiskey was consumed last night. I will talk about it briefly though. So this is the empty bottle now. This was day 2's bottle. And it was the Penderyn Celt whiskey. It's 43% alcohol. And I can still get a good smell out of the empty bottle. That's the nice thing about whiskey is the smells tend to stick around as long as you keep them bottled up and capped. It was pleasant. It was lightly peated. It wasn't a heavy peat, but it definitely had kind of that iodine-y saltiness to it. But there was some other flavors in there too. My wife got a little bit of sharp apple or crisp fruitiness. I, on the other hand, got a sweetness that seemed kind of a little citrusy in there, is what I was picking up. But it was pleasant to drink last night. And today, while I code, I've got a little coffee instead. So we'll hop in and start talking about what the elves want us to do this time around. So in day 2, we are taking a hike, and while we're taking a hike, the elves want to keep me entertained, I guess. And so they want to play a game, and this is a game that I don't fully understand the purpose of the game, other than to exercise your brain a little bit, I guess. He's got a bag, this elf, and it's got colored cubes in it, red, green, and blue. And we don't know how many of each are in there. And he will reach in, grab out a handful of cubes, and show us how many cubes he got. And he'll do that several times in one game. And at the end of the game, then he'll move on and start a new iteration of that game. Nothing really seems to change other than the game is just decided when he started a new game. And what he then tells us is that there was if the bag only contained a certain number of each cube, we want to determine, which of the games could legally have fit into that. Okay, so some of the games look like this. Game 1, he pulled out 3 blue, 4 red in the first round. And in the second round, he pulled out 1 red, 2 green, 6 blue. And in the third round, he just pulled out 2 green. And he did several of these games. So each one of these games would only be possible with certain numbers of cubes in the bag. So in his question, he said, what if the bag had 12 red cubes, 13 green cubes, and 14 blue cubes? Which ones would be legal? So we can kind of look and see that like game 3 wouldn't have been legal because there were 20 red in one of the rounds, and we know that there was only 12 red in the cubes. So that's kind of the setup there, and we need to figure out how to solve this. Anytime we have something like this where we've got this input that is not necessarily in what I would consider the best way to figure out the answer to this question, I start to think about, well, how can we shape this input into something that is easier to work with to answer some of the questions. And so I want to create kind of a data structure for each one of these games that will tell me in a more structured way about these games. And then it would also help because what we need to know is he wants us to determine which one of the games are legal for his theoretical bag contents that he tosses out. Well, we know that something would be illegal if any of the rounds had more cubes of a certain color than is available in the bag. So in my mind, I immediately start to think is that in the data representation of this game, not only do we need to know what the rounds were, but we also need to understand what the highest number of any of the colors were in any of the rounds. That way we would know if it would be a legal one or not. That's how I think about it anyway. I'm sure there are other possible ways that we could go through this problem. So with that in mind, let's start out with the Elixir solution first. And in the Elixir solution, what I want to start with, well, let's start out a module for ourselves. AOC, day O2A, and as usual, we'll use AOC to get those little helpers and whatnot. And last time I said it was kind of nice to layer in those types and specifications first, at the end, and to kind of add some documentation in. Now I want to kind of think about those types and specifications up front, because again, with this exercise, I want to figure out how to transform that input into something more structured. So let's think about what kind of things that we need to have. So we've got a type and we have a cube color, right? So we want to keep track of what are the legal cube colors. We have red, we have green, or blue. We also know that each game has an ID, because the whole point of this is once we figure out the legal games, we want to take their IDs and sum them up, and that'll be the input to see whether or not we get our star. So we want to keep track of those IDs. So an ID is just an integer, but again, I kind of like to be explicit with what is this thing that I'm dealing with here that I'm extracting out. So I've got an ID that's a type integer. And we are in each game, we are pulling out groups of cubes. So you could call it a group of cubes. I was thinking of him pulling it out, so I called it a pull. There's any number of ways that you could call this thing. I'm going to call it a pull. And a pull is simply a map that has a color going to the number of cubes in that color. Okay, so we're going to say, and because each pull doesn't have to have all the colors, we're just going to say it's an optional cube color, and that's going to go to a just an integer account. We could have made a special thing called a cube count or something. I think that's a little overboard, maybe not, but I just kept it as an integer here. Now we want to define what a game is, okay? So a game is something that it's a map, and it's got our pulls, and the pulls are just going to be a list of pull, right? Because we're pulling multiple times and creating these pulls inside of our game. Each one is kind of a round. We could define a round, but we define the pull, and a pull is basically a round. So we've got a list of pull, and we also want, like I said, for each game, we want to kind of keep track of these maxes, right? How many, what is the maximum number for each color? So what I did is I just said we have this thing called maxes, and even though it isn't a pull itself, it is kind of a meta pull, if you will. It's got the same structure as a pull. So we're just going to use a pull as the type there. And finally, I don't know if we'll use it, but we've got a type games, And it is also a map, and this time we've got an ID that goes to a game. So as we parse out our input, we'll turn it into a map where we take the ID and we send it over as the key, and then the value for that ID is the game itself. So now we've got the basics here. The other thing we need to know is the elf said that there's this theoretical bag that he wants us to compare the games to determine whether or not they would have been legally fit into the bag's contents. So we're just going to define bag contents here as a map, and we will say red 12 because he said 12 red, and then he said 13 green, and finally there were 14 blue ones. And again, this is a constant thing. We're going to compare it every time, so I just put it up here out of the way rather than keeping it in line down in our actual code. So let's define our solution. So we have to have a solution function based on the contract of using AOC, and it takes in a path, and we're going to do some things. So we're going to send the path into our readLines function, and that's going to spit back out all the lines that are in there. And we know those have new lines, so we're just going to map over that, and we are going to map with string.trim. And then we need to parse each game. So each line will be a game, and we're going to parse each one. So we're going to map, and we will parse the game. It just takes a line and it will parse. And we're going to spit back out tuples just because that's going to be easier. And so we'll just, a list of tuples. And so we'll just turn that list of tuples into a map with map.new. So the tuple will have the ID and the game. And turn that into a map. And then finally, we know that in order to answer the elf's questions, we want to figure out which of those games are legal. So we're going to find the legal games. And once we've got all the games that are legal, I'm going to have that just return a list of IDs of legal games. So to answer the question, we have to sum those up. So we'll just do an enum.sum. And that will tell us how to get the answer. Now we have to fill this in, obviously. We've got to define how do we parse the game, and then finally, once we parse the game, how do we actually determine whether it was legal? And so the first thing we're going to do is define that parse game function. Let's scroll up a little bit. And we know that the parse game function is going to, we want it to take in a string, right, which is just a line, and we want to spit out that tuple, like I said, for that has the ID and the game. And, whoops, it got rid of my opening brace there. There we go. We'll define parse game as taking a line, and we want to basically take our line and split it on the colon, because in the example, we can look back here, it's game 1 colon and then the results of that game, right? So we can do some pattern matching here, which will help us out. So if we split it on that colon, we know on one side we'll get game space, and then we know that we will have concatenated with our ID, and then the other piece of that array will be the actual like raw game information itself. So we'll say that equals string dot split, and we're going to split that line on colon space. And that will give us the ID and the raw game. And so now we want to find our polls. So our polls, we're going to just call another function to keep this function tight. And this new function will be responsible for parsing the polls from our raw game. And once we have the polls, now we can return our tuple, right? So we have to convert that ID into an integer, and we want to return a game. A game has polls, and we'll give it our polls, and it has maxes, and we are wanting to use those polls to find the maxes. So we'll just call find maxes with our polls. And that should give us the return that will return out what we need, right? And so now we need to parse the polls. When we parse the polls, again, we're taking a string. And this time we are going to return a list of poll. We sent it in a raw game. And we're going to take that raw game, and each poll was separated with a semicolon. So Copilot's helping out, doing exactly what we want there. String.split, and we're going to split on the semicolon space. And each one of those will then be a poll, and we need to parse each individual poll. So we'll scroll down again and define out parse poll, which also will take a string. And this time we're going to spit back out a single poll out of it. So parse poll, and we'll use raw poll there. And we want to take our raw poll, and each poll, the colors and their numbers are separated by commas. So we're going to take string.split, and this time we're splitting on commas because that's how they had them separated out. And for each one of those, it's going to be a number and then a color. And so we want to parse that, right? So we're just going to map over each one of those, and we're going to parse the color. Could be parse cube, I guess, might be better. Let's do parse cube, because that's kind of what we're doing. We're parsing the cube. That makes a little bit more sense. And then we say map.new, because when we parse the cube, we're just going to get a tuple again. It's the easiest thing to do there, and turn it into a map. So how do we parse the cube there? So parse cube. Again, we give it a string. And now we are going to return a color and an integer, because this is we call map.new, which is going to turn this into our map that back in our types is what we defined as a poll. A poll just maps a color to a number. So we'll parse the cube here. And actually we don't need to pipe here, because this is just a simple space delineation. So the first thing it had was our count, and then it had our color, and we'll just split the raw cube on a space, because it was like 5 space red, etc. So now that we've got those, now we can just return a tuple by doing a string to atom on our color, and a string dot to integer on our count. Now we've got everything parsed out. We're completely parsed. If we scroll back up here, this all folds back up, and this gives us, the polls here. And then with those polls, that is a list of our poll type. We now want to find the maxes, and a max is just another poll type, but it's got the max for each color in it. So we want to find those, right? And so how do we find all of our maxes? Well, we'll just start coding that out. So find maxes takes in a list of poll. We are finally done taking in these raw strings out there, and now we want to return a poll though, because a max is just the poll. And what we'll do here is in find maxes, we want to basically cycle over all of the polls and figure out what the highest value in each one is. The easiest way I need to know to do that is do a basic reduction. So we'll do polls enum.reduce, and we'll reduce well, we want to start with our maxes. Since we know our maxes is a poll, and we want it to have all of the colors, then this will be kind of our base max. So 0, 0, 0, that would be if none of the polls ever pulled anything out. And then we're going to go over our polls, and we're going to basically update the maxes with each poll. All right. And that's going to take 2 there, 2 arguments, because we're going to get the poll, and then we're going to get the current value of the maxes that we're generating. And now we can update our max, our find max. So we'll say spec update maxes, and this time we're getting a poll and another poll, and we're returning a poll. So we're taking a list of polls and a singular poll, and we're spitting out a singular poll. And then update maxes. We've got our poll and we've got our maxes. And basically for updating the maxes, what we want to do is we want to, for each of the colors in our maxes, we want to update it based on the information from the poll, right? So we're going to send maxes into a map. So we're going to map over the maxes, and the maxes is just a poll, so it's a color, right? And a value. And then we're going to update the max. And we're going to update, when we do a map, we would typically only get 1 argument in, but we actually want to include the poll as well. So we're going to use the other form here, where we're going to say, send in our max, but also send in this poll, right? And then that way we have, we'll get back out a list of tuples. So we're going to have to map.new again on that. And now we will update our max. And our max is going to take a poll. Our update max function is going to take a poll, and it's going to take poll. Actually, it's not going to take a poll. It's taking a color and a count, right? Because we're cycling over what's in the maxes, which is key values, color and count. And so what we want to do then is, and color isn't a type, I think we called it cube color, right? Yeah, there we go. And we don't have a count, we have an integer. There, that's what our spec looks like. And what do we spit back out? Well, we spit back out the updated cube color and integer. That way we can fold that into the new map for the maxes. that needs to be in braces. Don't take those braces away. All right, update our max. This time we'll take our color and our count, and we'll take our poll. And what we want to do is return the color, and then we want to take the max value of the value from the poll itself. So we'll do map.get on our poll, and we want to pull the color out of that. We want to take the color key out of that poll. We want to default to 0 because not all polls have all the colors in them, right? So like remember in the game 1, there was a poll that just had green. So if we try to pull the color out of the poll, we might get nil, and we want an actual number so that we can have our max determine the max correctly. And then we want to compare that to our count. So we're taking the max of the color from the current poll versus the count that we already have in the max, and we're just going to return that out. So that will reduce down, and our maxes will be updated to be the most for every single one of those. All right, so now at this point, our game is fully parsed. So parsed game, we have the ID, we have the polls, we have the maxes, and now we are ready. We fold that into a map, and now we can look for our legal games at this point, right? So a legal game, if you remember, is one where the polls in a game all would be possible with the theoretical bag that the elf gave us. So we'll just go down here, and I like to put this at the top rather than at the bottom. We've been folding these functions down, except that was all of our parsing logic. Now we're talking about how do we actually find the legal games, which was kind of the whole point of this in the first place. So I just put it at the top. It just feels a little bit more natural for me. And so we're going to find the legal games. And it's going to take a games, which is that map that goes ID to game. And it's going to return a list of IDs, a list of integer. Since it's a list of IDs, let's actually say it's a list of ID. So each one of these games, we can map over the games, and we want to filter out the ones that are actually legal. So we will say enum.filter, and we will filter for a legal game. And once we have all of the legal games, then now all we need to do is new that back up into a map, because again, anytime we do like a filter, an enum function on a map, we always get a list of tuples back. So we're just going to map.new, but we only want the keys, we only want the IDs. That's what we want to return out, as a list of IDs. So we are going to return map.keys. Let's take a quick little sip of coffee. There we go. That's a little bit better. I felt my throat getting scratchy, probably not pleasant for you all to listen to. So now we need to figure out, how do we define what a legal game is? A legal game takes a game, and it returns a Boolean. Actually, legal game doesn't take a game, because if you recall, we're mapping over, I guess we could have pulled the values out, but we still want the IDs later. So it's what we are passed in is a tuple of an ID and a game, and we're just going to ignore the ID part, right? So legal game, and this will take an ID that we don't care about and a game. We could not care about it because this is a filter function. All we're returning is a true or false Boolean, the ID will still be there in the filtered results. And for this, what we want to do is a game is legal if all of the pulls are legal, right? So we can basically just define this as enum.all are all of, actually we can pipe the game dot pulls. Can pipe that into an enum.all, and we want to basically say, is each one of these pulls a legal pull? And that should be pretty straightforward to determine whether it's a legal pull or not. So how do we know if it's a legal pull? Well, when we get a pull in, then we want to say a pull is legal if all of the counts for the cubes, cube colors in that pull are legal. So we'll again just enum all, is this a legal cube? Cube color, cube, I don't know. We'll just say legal cube and define it like that. And a legal cube takes where a pull is a map, so it's going to give us a cube color and an integer in a tuple there, and we're going to return a Boolean. Takes a color and a count. And let's see what we're being recommended. Yeah, that looks right. So we want to basically check, is the count less than or equal to when we pull the color out of the restriction, the bag contents that we defined at the top of the file. And at this point, we've filtered down, we've created all the filter functions. Now that should find us all the legal games that are IDs, and then we sum them up. At this point, I believe we are done, and so let's try and test this out, right? Let's pull this up over here. And we have a problem. Color is undefined. All right. So I called it cube color up here. I probably should have just called it color because that just bit me. So let's find where we defined color in one of our specs. We probably said color instead of cube color. Let's search for color. Ah, there it is. Cube color. There we go. Hopefully that was the only one. That was. All right, we are good to go there. And we will run it on our test input first. day02a dot solution. And we're going to give it a path. Our data is up a couple directories. day02 test.txt, and it can't find, oh, that's it. Did this yesterday too. It's in the data directory, up a couple directories. There we go, 8. I believe that was the right answer for the test data. Let's go back over here. It suggested that in this example, if we take the sum of all the IDs that are possible, you get 8. Perfect. So that looks really solid there. So let's try and run it on our full data. 2563. And that does look very familiar. So I am fairly certain that if you stick that in, you will get your first star. So we did great. Got that one done. Now we can move over to part B. Part B, the instructions were that we found out that they've stopped producing snow after we got done with our walk, and that's a problem. They have to work on fixing it. But since we have more time to waste, the elf put forward another question, and he said, hey, for each one of the games that we played, what's the fewest number of cubes of each color that could have been in the bag to make the game possible? So rather than compare against his theoretical bag, we want to figure out what's the smallest number of cubes of each color that would have to be in the bag to make that game possible. And this is where sometimes Advent of Code just gives you something wonderful depending on how you choose to solve part A. Because if you think about it, for part B here, it's asking us something that we already did in order to solve part A. It's asking us to figure out that maxes, okay? And what it just wants to transform the maxes a little bit. So what it wants is when you figure out the number of cubes needed for each game, then you multiply them together, and then they want us to sum those up. So they call the multiplying the cubes together into, they call that a power. And then they want us to just sum up the powers. And so what we're going to do here is we could do something like, extract out a bunch of functions into a shared module and then import that module into both of these other modules. Maybe that'll be part of a cleanup. But for now, what I think I'm going to do is just copy everything that was in part A, and we're just going to paste it into part B. We're just going to rename our module to part B. And our types are going to be the same here. We don't need bag contents anymore because that's kind of what we're going to be figuring out. We do need this concept of a power though. A power is just an integer, but I think it helps to think about these things as what are we calculating, what are we figuring out. And we're going to change this. So actually, after we've parsed the game, that logic all stays the same. But rather than finding the legal games at this point, what we want to do is basically, after we've parsed the games, then we want to calculate the power for each game. And so we will just map over and calculate the power. And once we've calculated the power, we just need to sum them all up. All right, so we don't need this stuff about legal games anymore. We can get rid of that, get rid of the legalese, we don't need that anymore. We still want all the parsing logic there, but now we can calculate the power. And since we're mapping over that list, we're going to get out, mapping over that map, we're going to get out a tuple with the ID in the game, and we're going to spit back out a power. And we don't care about the ID now, we just want the game. And to calculate this out, we want to use those maxes, right? So the maxes give us the answer that we want already. So if we just take the game.maxes.red, so that's how many red cubes were in the max. We're going to multiply that by how many green we had and how many blue we had. And that's our power. We're done. That was that. And so this was super simple and easy. We'll save that. Let's pull this back over here. And we'll run, on our test file, we'll run this B solution here, right? 2286. which it said we should get 2286. Perfect. All right. We'll run this on the full test data. And we get 70,768. So that is what we would plug in, and we would get our second star. And we have solved now with Elixir day 2 advent of code. So what about Ruby? Well, there's probably a lot of different ways, as usual, to do something in Ruby. My Ruby is probably going to end up looking a heck of a lot like my Elixir, because I tend to write very functional Ruby, and so I'm going to write very functional Ruby, and the Elixir was a functional solution, but it's going to end up shaping up a little bit different. Since we know going into this that we are going to keep the parsing the same between both, and Ruby allows you to have subclasses, I thought I was today going to implement a new top level class that I could reuse to do the initialize function in each one. So I built that out first. So I made a new class called day, and it just has an initialize that takes in a path, and it sets our variable to path, so that when we initialize it with the path, now we have a class that we can work on. But now, thinking that for our day 2 solution, A and B, the parsing is going to be the same. So we can create a class that just does the parsing. And I am going to call that day 02 RB. And I realized that I've got my solution here already. I didn't wipe that out. Let's just wipe that out. Let's put this brand new in, because that's the whole point. We're trying to kind of learn how to go here. So we are going to say module day, no, this is module AOC, class day 02, and it's going to subclass from that new day class that was out there that we made. And with this now, what we want is we want a function that knows how to parse the games. So that's going to be the shared functionality between both. Parse games. And we want to make it, because this is object-oriented and we can stick state in places, we want to go ahead and make this so that when you parse games, it remembers what the games were. But we also want to make it so that we don't reparse the games all the time. So we're just going to say games or equals the file dot readlines at path. And what we want to do is we want to chomp these, because we want to get rid of those new lines. And we're going to want to map over this. So we'll map, and we'll call method parse game. And then, just like we were doing map.new in Elixir, we want to call 2h to turn this into a hash here in Ruby. Then we're going to go ahead and have some private functions. We'll take a line out of the input there. And if you recall, what we did last time is we split on the colon. And so we're going to take we can't pattern match all the way. I guess there's pattern matching in Ruby now. I need to learn more about the new Ruby pattern matching. It didn't used to be there when I was doing Ruby back in my day, but I know that I can at least do this. So I can get my game reference and my raw game. If we split the line, on colon space. So that'll give us the game reference up front, and then the rest in the back there. And then we can do the same thing to pull out. We ignore the part that says game, and we want to keep the ID, and we'll say game reference dot split, and we'll just split on the space there. So because they all said game and then the ID. So we're going to throw away the part that says game, and we're going to keep the part that has the ID there. And now we want to parse our polls just like we did last time. So we'll call parse polls on the raw game. And then we want to return out, much like we did last time, we want to do id.toI, turn that string into an integer. And then we want to return a hash that's got our polls and our maxes, that we want to find our maxes with the polls. And we'll return that, and that'll get turned into our hash, and that will be roll up into our games, right? And so now we want to parse our polls. Parse our poll with our raw game. And our raw game, we're going to want to split on the semicolons, because that's going to turn it into the polls that we have. And for each one of those, we want to map, and we'll call a new method called parse poll. And that will now parse out the poll and return that up. Scroll up a little bit. Help if I move my fingers over. Parse poll. Got a raw poll. Again, these are all strings, but we're not defining specifications here in Ruby types. So we've got our raw poll, and we're going to split it on commas this time, comma space. And that'll divide up into the different colors that we have. And we want to map that over parse color. And that'll be the end of parse poll. So we'll parse color, and that'll take a raw color, and now we're going to split on the space. So we're just going to split a space, and that will give us, we can capture that into the count and the color. And what we want to return is the color dot toSem, and to turn it into a symbol, because I kind of like the idea of symbols for our colors. Red, just like we were using atoms in Elixir, and then we're going to toI on our count. So this will return back and get turned into a hash with this array here. The next thing we need to do is we need to find our maxes, because we take in our polls and we find our maxes. So find maxes with our polls. And when we find our maxes, we want to do a reduce again, just like we did in Elixir. So we're going to reduce our polls, and we're going to give it a starter. So that'll be our starter hash to work with. And then we want to call method, and we'll call this update maxes. Excuse me, I better take a sip. There we go. Close that method out, and we will define update maxes. Maxes takes It's reversed in Ruby. I had to remember that. Did it wrong the first time until it didn't work right, and I was like, oh, that's right, got to reverse those. When you reduce in Ruby, you get your thing you're building up first, and then you get the item from the list. And so we'll update our max, and we're just going to update our maxes by mapping over it, and we're going to get our color and our max, and we want to turn that into a color, and we want to use our max, and we want to pull the we want to take the color out of pull, but rather than referencing it directly, we want to use fetch so that we can default it to 0 like we did in Elixir. We defaulted it to 0 because it might not be there. And we want to, of that array of the max and the value from our pull, we want to find the max by calling .max on it. And that's going to spit back out a set of a list of that we can turn into a hash. So we'll just 2h on that. And now we've done all of our parsing. So this should be right. If there's an error there, we'll come back and fix it, but I'm pretty sure that this will take us through and we can go in to work on our actual day 2A solution. So for our day 2A solution, this should be shorter because it's just the part for finding the legal games, right? So take another little sip here. It's too bad that's not whiskey. Maybe I should have broken out day 3's whiskey, but we'll do try and do the video for day 3 tonight. So we'll use our whiskey for there. We'll pop open our AOC module, define another class, day O2A, and it's going to subclass from day O2. Close those out. And we, just like before where we had kind of the target bag that the elf gave us, we're going to do that here as well. So we're going to take our bag contents, and that's equal to a hash that has red 12, green 13, blue 14. And now we can define out our determine legal games, which was the whole point. We want to figure out our legal games here. And we're going to parse our games. And then after we've parsed our games, we know that we've got games, and we want to select out all the games where the game is legal. So we'll just filter, and in Ruby it's called select, and once we've got all those, we'll stick that back into a hash. We only want the keys, and then we want to sum those up, and that will spit out our answer. So we'll go ahead and put a private on here. How do we determine a legal game? Well, a legal game is one where all the pulls on the game are legal. And that's what a legal game is. So how do we determine if a pull is legal? A pull is legal if on the pull, if all of them, where a pull is just a hash with key value, color and count. So we'll just take color and count. If the count is less than or equal to the bag contents, the color from the bag contents, then we know it's a legal pull. And that right there is all we need, because we did all of our parsing in the superclass there, we can pull over our console and check if we did all this right. So bin console, and what we want to do here is, let's say solution equals AOC day 02 a dot new, and we'll give it our path, data day 02, and we'll do our test dot text solution dot determine legal games, and it says that it can't open that file. So oh, I said text, not text. Change this to test. Now when we go, all right, now it doesn't like, we've made an error in our parsing. So let's go, it's looking at on here, so polls equals parse poll with raw game. I called it row game here when it's supposed to be raw game. That should be an easy fix. Exit out, pop back in, get our solution, determine the legal games. We still have a problem. Oh my gosh, this is what happens. My Ruby is so rusty. I make errors like crazy. So we try and fetch out the color, and it can't convert the symbol into an integer. All right. That seems a little weird. So what is going on there? Let's go look. That was in our parsing again. So it's complaining about here, where we're trying to pull the color out of our maxes, or out of our poll. Let's see here. What did we not do right? We've got our color, that should be a symbol. It was complaining no implicit conversion of symbol into an integer, so I'm not sure of why it was even trying to there should be no integer. Symbol is So let's see where we parse out the color and the value. So we've got our raw color, we're splitting on the space, and we pull that out into a count and a color, and we turn the color into a symbol, and we turn the count into an integer. That's what we do when we parse our color, which will then get rolled up into our poll. So when we have our poll here, we should be able to fetch out of the poll the color, and we should be able to get the color out and default it to 0. All right, that's not right. So something else must have been wrong here. So when we parsed our polls out, we store them as our polls. And then find maxes takes our polls, find maxes, reduces over the polls, and it starts out with a hash that gives us our starter values, symbols to integers, and then we call update maxes on each one of those, which should take our maxes in our poll. We want to map over our maxes. this is where having the types that I do in Elixir is helpful here, because I could easily determine where maybe I was messing up on some of these. But it seems to think here that when I fetch the color out, I'm not getting an integer, I'm getting the symbol itself, which it wants to turn into an integer so that it can do the max. This doesn't make any sense. All right. Let's start at the beginning. When we're parsing our games, we're reading in, we're chomping off the new lines, we map out, and with parse game, and we stick it into a hash. When we parse the game, we get our game reference and our raw game by splitting on that colon, so that's right. And then we want to just pull the ID out by splitting on the space. And then we're going to parse our raw game into polls with parse polls. And then we turn our ID into an integer, and we return a hash that's got our polls and our maxes that we find with the polls. We parse our polls off of the raw game, and we split that on a semicolon, and for each one of those we parse the poll. And then when we parse the poll, we get our raw poll. We split on the commas now, and for each one of those now I see the problem. We didn't to H, because a poll is a hash. This is where it would have been nice to remember that we return a hash from this function. All right, that was my bad. I bet you anything that that's enough to fix it. So let's pull this back up over here, exit, pop back in. I hope it makes sense and is interesting for you folks to see me troubleshoot. You know, I'm doing these things. I'm realizing that there's bugs and errors along the way. All right, now we have a problem in legal game where it thinks that we've got the wrong number of arguments for our legal game. And why do we have the wrong number of arguments for our legal game? So that's this here. Oh, that's right, because again, we're going over a hash. So we have to take our ID in, but we ignore it. So that'll be good there. We'll save that. And exit out. Clear out. Get our new solution. Try running our solution on legal games. 8. That's what we were looking for. That took us a little bit. Now if we do our solution on our test value without our test, so it's our real stuff, determine legal games, 2563. That's the same answer that we got with the Elixir. All right, now let's do the second part. The second part should be super straightforward and easy based on everything that we did both in the Elixir and in the Ruby. So we will crack open our AOC module again, define our class of day02b, which is a subclass of day02. Close that all out. And now what we want to, we don't need bad contents for this one, so we are just going to define, we're going to sum the powers of the game. And that's going to simply need us to parse the games. So we'll make sure the games are parsed. And then we can take the games and we need to map them into the powers, right? Calculate power. And then we can just sum those up, because that's all we need is the sum. So might as well make this private. Calculate power takes don't get burned again, it takes an ID into game. And now we want to take the game and we want to use its maxes. And we want to use the red value from the maxes and multiply it by the green value and the blue value. And then that should return our power, and that should be all we need for part B. Now that we fixed all our parsing problems anyway, that shouldn't be an issue. Pop back into our console, AOC, day O2B, new, give our path to test.text, and we didn't save that as a solution. It's equal V, right? Is that Ruby? No. I don't. I know that there's a way you do that in Ruby. Okay. Solution. Sum the powers. 2286. That was our test value, and that was right. And then now we'll run our full value, and 70,768. And that right there is the same answer that we got with our Elixir. The Ruby, once again, was a little rough. Made some mistakes along the way, had to track down where I messed up the thinking on some of that. And it will get smoother over time. But I hope me kind of tracking down and trying to figure out where I went wrong was interesting. It shows that everyone makes some mistakes, I think, but hope this helped in understanding both a little bit of Elixir and a little bit of Ruby, and we will be back. I'll probably try and record part 3, day 3, tonight, and this time we'll have some whiskey to sip as I open up door number 3 on the Advent calendar, and we will see what that brings to our palette. Thank you all for taking the time to watch.